Um, Today, it's as we restart our speaker series for the new term. It's a pleasure to introduce Professor Scott Stevens, who's a professor of environmental science, policy, and management at the University of California, Berkeley. Professor Stevens has had kind of a peripatetic career, or at least he did until he came to Berkeley, where he's been for 18 years. But before that, he was an undergraduate, actually right in our fair city at Cal State Sacramento, and then went on to get his PhD in Berkeley, then worked in government, and later became a professor at Berkeley, where he does research on fire science and consults extensively with all branches of government. And obviously his topic is extremely timely, so it's really a pleasure to have you here, Professor Stevens.
For sure. Well, I'm happy to be here today. The idea would be to kind of provide a little background on fire in California, and then some ideas of managing fire, how we might do better. And then I've kind of set that up then thinking towards the end of the talk, we can talk about fire policy, some initiatives that I've been thinking about. So, and I know at the end of the talk, I plan to have hopefully at least 15 minutes for questions. So I hope you'll ask me some questions because I'm always happy to have questions. So the outline of the talk, you can see, I really wanted to provide kind of a background of fire in California and also fire in the United States, some of the kind of principles, some of the issues that we basically are foundational. We'll talk about that. And then I really want to maybe talk quickly about fire policy development in the United States. How did we get here? So we'll talk about that. And when we think about how forests have been changed by the way we've managed in the last 100 years, removing fire, harvesting, things of that nature, I want to speak to that for a moment. And then look at some recent data about how are we doing in terms of Sierra Nevada resilience adaptation to climate change. What kind of window might we look at right there in terms of how we're doing as a society, as a people who live here in California. And then lastly, I'll talk about ideas for a new federal fire policy. And some of those will have some connections to the state as well, and we'll then go from there. So I wanted just, for folks that hadn't seen much fire, here's a picture of a fire that I did, a prescribed fire, several years ago. You can see it's in Ponderosa Pine Forest. And we classify fires by really their ability to kill the dominant organism. So if you're in a forest, low severity fire simply means you're not going to kill many of the large trees. Most of them are going to survive. And that's exactly what we see in this picture. That picture is not going to kill many of those large trees. They're large enough, bark is too thick, crowns are up in the air, so you're going to have the majority survive. So we call that low severity. Reduces the woody vegetation and woody fuels as well to keep hazard down. How often did these fires occur before really the current culture showed up? About every 5 to 25 years, both from lightning ignitions, also from Native Americans, so from Indians, Native American people. They burn for a lot of reasons: food, medical supplies, travel, just a litany of reasons where fire was one of their most important tools for managing their landscape. But today, we look about estimates of how much fire used to happen in California. I wrote a paper with some colleagues in 2007. We estimated about 4.5 million acres burned a year. 4.5 million acres is a lot. But down below that, you see that I have an estimate of what currently has been burning, around 10%. That's changing. This last year, 25% of that burned. We actually burned over 1 million acres in California. That's a huge number for us in the recent past. So we've seen fire area actually increase, I would say, somewhat substantially in the last 5 to 10 years. But when we look at how much fire used to occur in California, say pre-1800, we think around 4.5 million acres. So a massive amount. So this year, I think we had about 1.15 million acres in terms of the fires that were some of the many fires near Santa Barbara, Napa counties, Sonoma counties. Well, how do we ever get here and why? This is always something I've always tried to read about. I'm always curious of just our history. I mean, if we don't look at our history and learn from it, I don't know how we can be a human civilization, right? So here we look at why did it happen? Well, the reason was that in the early 1900s, there were really practices that were occurring that were destructive to ecosystems, like early settlers burning to clear land, sometimes for mining. People harvesting trees, leaving dead and down woody fuels behind in horrendous amounts and then burning afterwards. Huge amounts of burning. And even the idea that you had grazing. Sometimes grazers would burn areas after grazing to try to get forward. So that as a backdrop was a challenge to ecosystems. Another reason is people, when they first came to California and started to think about our forest, they really thought the forest was understocked or it had very few trees per acre, and they thought the culprit was fire. Well, they were right. Fire was actually reducing tree density, keeping it down in terms of number of trees per acre, but still facilitating large trees, big spacing between trees. So they thought if we could get that fire out, we can get more trees per acre and grow more timber or lumber for the U.S. public. And that's why we began that whole conversation of fire suppression. That all happens around the early 1900s. When you look at the history of national fire policy, no state has a bigger influence than California. In fact, California is the state that actually does a lot of the early work, studies, and also the politics of fire. It becomes national. We'll see that in a moment. If you see some ideas of that importance of California, regional forester, that's the regional forester of the U.S. Forest Service, the person that basically oversees all of California National Forest. Du Bois, he tells the supervisors shortly after he's basically appointed that one of their top jobs is to get fire out. In 1914, he writes a paper, 1914, A Systematic Fire Protection in California Forest, and that's cited as one of the most influential papers in early fire control in the history of the United States. 1919, the Forest Service tells its people to keep putting out fires, and by the way, even do it on private lands, even without people saying that you can do it. There was some federal legislation that enabled that, actually. 1924, based on my reading of the history, that's when the California Board of Forestry here in Sacramento says fire suppression is the policy, fire exclusion. 1935 is interesting. Right here at Mather. Mather is Mather Air Force Base used to be here. Now it's gone. But Mather was a host of a national meeting on fire by the Forest Service. All the big cheeses came, and they came up with this idea of the 10 a.m. policy. The 10 a.m. policy sounds incredibly simple. Basically, what it says is you detect a fire, it's out the next day at 10 a.m. And you basically staff yourself. You basically learn how to put fire out. So the 10 a.m. policy becomes the policy of the nation. Really becomes total policy. That didn't change until 1991. So the 10 a.m. policy sounds so simple, but it really was how the fire apparatus began to grow and actually evolve. So if you're going to get all fires out by 10 a.m. the next day, you better staff, you better have equipment, you better have dispersed resources, you better have detection, you better have all this stuff. That's exactly what we did. And today we put out 98% of all fires below 300 acres in size. That's testimony to the early ideas. Man, you're putting out 98% of them, but the conundrum is the 1 to 2% that burn 95% of the area. So you get out almost all of them, but the few that get away get big. 68 is a big year. That's when the National Park Service actually changes fire policy. It actually says we're going to allow prescribed burning to occur, people putting fire on the ground for an objective, and we're also going to allow lightning fire to be actually occurring in remote areas. Before that, the National Park Service put out every fire, just like the Forest Service. They're no different. Okay? 74, the Forest Service comes up with a directive to try to change fire policy. They go to fire management instead of just fire control. But if you look at really the rubber in the road, really haven't evolved much in their really systematic look at fire. We still have an emphasis on fire suppression today and budgets that are over $2 billion a year just in federal fire suppression expenditure. Budgets have just skyrocketed. I remember in the early 90s, the fire suppression budget was about $400 million. About $400 million a year. And now we're at about $2 to $3 billion. So that's what we have in terms of just the cost. I see no reason for that to stop going up. Okay. What about things could have been different in California? It's interesting, the light burning controversy. Light burning was something that actually started in California again. So it's interesting how so many things are right here in our state in terms of actually impacting what was going on. Light burning was actually practices by private forest owners to reduce fuel hazards by burning somewhat similar to Native Americans and also early sheep grazers. And it started right here in the state, the Walker family. The Walker family owned around 750,000 acres of forest. They came from Michigan. They basically came across when they basically cut down all the forests in Michigan that they owned. And they came to California near Lake Almanor. Lake Almanor is in the southern Cascades up here in northern California. They bought a big area of forest And you can see these are actually some pictures from the 1920s. They had a sawmill, of course, and they harvested timber. But one thing they did is they thought that burning their forest land was essential to its conservation. And they began to burn in earnest, tens of thousands of acres every year in the early 1900s. It was at odds with federal policy beginning, Gifford Pinchot and others trying to say we need to get fire out of the system. They were convinced they needed to keep it in. And this went on as a debate for at least 20 years. Clinton Walker was actually the son of T.B. Walker. T.B. Walker was the person that came over from Michigan in the early 1900s and bought the land. He wrote a letter in 1938 that I actually have a copy of, and he's writing basically about the conversation that his father T.B. had in early 1900s. And there are some quotes from the letter in there. The general condition of the forest when the white man first came to California was very excellent. Then the foresters came from Yale University and put a tourniquet on the forest. I would prefer to remove the tourniquet in our timber matters, which is a lack of fire. So these are quotes from T.B. that Clinton Walker recorded in his letter in 1938. Here's some more quotes. So T.B. is saying, I requested permission to burn from the state forester and U.S. Forest Service Du Bois. Both refused. We proceeded to burn anyway, and Chief Forester Graves was then the chief of the U.S. Forest Service in Washington, D.C., came out from Washington, and Du Bois and many others with cameras and notebooks to get damaging evidence. They stayed several days and followed the burning, with comment by Graves that the work was excellent. Du Bois apologized to me for panning me in the newspapers previously. Amazing. In some ways, right there in the early 1900s, there was a group of people putting fire on the ground, thinking of long-term sustainability of forests, and actually implementing it right in our state. Eventually, they basically lost high ground, and they basically were not able to continue it. But I find it fascinating that there were a group of folks that actually practiced this and actually had the foresight to think of forests into the future. And they did this not really for conservation. They did this because they wanted their timber resources to be preserved and actually be able to maintain those resources into the future. And they were concerned that if we remove fire from the system, eventually fuel loads would get too high. Inevitably, they get a fire in their ground, and they would lose their timber. But it's an interesting part of our history in California. Well, eventually, fire suppression wins. So it basically comes up as the policy, federal level and the state level. William Greeley, who was the third chief of the Forest Service, states that the conviction burned into me is that fire prevention is the #1 job of American foresters. Scientific study is done on the merits of fire suppression versus light burning. This was actually asked for by the Board of Forestry. California Board of Forestry was interested in this. They were just not convinced that light burning was a bad idea, and they were wondering whether or not suppression or light burning should be adopted. Cho and Kotak then did this study. And then there's a quote there from the paper in 1924, pretty telling, that maximum protection or fire exclusion inevitably increases hazards by the encouragement of undergrowth is, of course, true, but such added hazard in no way vitiates the reason for protection. So even in 1924, there was some idea that if you took fire out of the system, there could be consequences in the long term. I found a fascinating account, an oral account of Shao. Shao actually wrote a summary of his life's career about 1952. And I got a copy of it from a colleague. I read the whole thing. It was intriguing. I hate to say it, but he actually comes clean. Some of the early research in the 20s, they actually falsified the data to show that prescribed burning was killing more trees than it was. He actually says that in his personal account. I found that really interesting. At least he told us. But in the 20s, there was so much momentum about the idea of trying to get fire out of the ecosystem that it just was carrying the day. You know, science solving problems, right? The idea that science and kind of, scientific thought, machines were just going to be able to solve our world's problems. I'm afraid that's never going to happen. But what about some changes to ecosystems? So if fires are burning every 5, 15, 20 years, they've been doing this millennia, and you take it out, you're going to change that ecosystem, right? I'm talking a whole bunch about forests. We could talk about shrublands. We could talk about grasslands. We'd have different conversations. The shrublands of Southern California really are different from the forests in Northern California. Grasslands are different than shrublands. So today we're talking, at least I'm talking, about really primarily the forest ecosystems in our state. Most of our systems in this state all had fire burning at 10, 20, 30-year intervals before suppression began in the early 1900s. So if you take that fundamental process out of the system, you're going to do a few things. You're going to potentially increase the ability for trees to survive and just grow, increase density. You're certainly also going to increase woody biomass, fuel in the ground, other things. And you're going to change ecological systems profoundly by taking that process out that's actually been working. Here's a picture I just wanted to show some of those characteristics. This is the Bear Creek Guard Station. Berkeley has a forestry summer camp that we actually teach an 8-week course. 10 weeks, actually. 10 weeks. We teach it every summer near Quincy, California. All students are available to go to it. But this is actually just above the UC Berkeley Forestry Summer Camp, Bear Creek. And here you can see a picture of Walter Robertson. I'm not sure who it is here. It's one of the two gentlemen. They actually built this cabin themselves when they were employed by the Forest Service, and they were forest guards. Guards simply meant that they were patrolling to put out fire, patrolling for unauthorized grazing, and patrolling for unauthorized timber cutting. So here you can see Walter Robertson and the Bear Creek Guard Station. These are big ponderosa pine. So these big trees you can see are ponderosa pine, both to the left of the little shack and also just behind it. You can see behind that thing for some distance, hundreds and hundreds of feet. You can see a snag here, a dead tree standing, some other trees. So take a look at the next picture. One of my friends, Ryan Thompson, took the same viewpoint 87 years later. So there's that big tree here, and there's the same one here. But you can see that if you take fire out of a system, and Sierra Nevada is a relatively robust system in terms of productivity. It's got deep soils, it's got pretty good water. It grows biomass. In fact, it grows biomass like mad. It's a very productive ecosystem. So if you take fire out of the system that used to burn every 15, 20 years, and then go 87 years forward, that's what it looks like. The next picture will have the picture half and half. So to the right, the current, to the left, 100 years ago. And by no means has every place changed this much, and I'm going to show you some data in a minute where we can have a bigger conversation. But this one picture of the Bear Creek Guard Station, the Plumas National Forest in the northern Sierra Nevada, is quite telling in terms of just how much forests have changed. When you go to this place today, forest is gorgeous. We've taken our students up here to this site for many, many decades. So if you show up there and you look at that forest, you go, man, look at that, beautiful. Multi-layered canopy, thick and green, gorgeous, right? It's a giant artifact of the way we've managed forests for the last 100 years. It's just that simple. That system has been changed so fundamentally that if you were actually in 1915 in this forest, you better bring a sun hat. You get a sunburn here. This is an open system, big trees, wide spacing. Over here, you can hang out in the shade. But it's hard when we look at this in a contemporary sense to think they've changed that much. Let's look at some data, then actually not just a picture. This is one of my favorite forms, USDA Form 321A. We found some of these. I know I'm kind of crazy. I get excited about this form. We found these in the Federal Archives in San Bruno, the San Bruno Federal Archive. These are forms essentially collected and recording an early forest inventory. You can't really see it very well. Date July 8th, 1911. So these are a systematic survey of early Forest Service ground, and we found a few of these for a few places. El Dorado, the southern Sierra Nevada, and then also here, the Stanislaus in Yosemite. What it does is it gives you essentially species, yellow pine, sugar pine, white fir, gives you species information to 2 inches diameter classes. So the next picture just shows us where do we get the data from. So each of these black lines you see in the picture is a transect. The transect is 2 chains wide, one chain 66 feet. And it was basically then a transect completely through that area, and every tree was tallied. Every tree was tallied. It turns out to be about a 7 to 10% sample of the area, which is a huge amount of sampling if you're doing this place this big. The whole area is around 40,000 acres. So each of these black transects were actually put in, and they were put in by the section corners. The section corners are simply the way we survey land in the western U.S. They're basically a monument every mile. So you can go to those section corners today and actually try then maybe to do a remeasurement of the same places done in 1911. And that's what we did. So this is, just wanted to show you, this area to the left is the Stanislaus National Forest. To the right is Yosemite National Park. So Yosemite is the lighter color, and then the darker color is a Stanislaus. It turned out this survey went over both of them. At the time, Yosemite was smaller. I didn't realize that. Yosemite actually, this used to be all Forest Service ground. Yosemite was way out here. It wasn't until the 30s that it popped out. So that's why the Forest Service actually did an inventory there. But what's the data tell us? Well, in one particular area, I'm going to show you a picture next. We see from 1911, there was something like 20 trees per acre above 6 inches in diameter. 20 trees per acre. We did this survey in 2013. We got to about 250 trees per acre. Okay, that is, again, not, I'm going to show, this is not every acre. Okay, but massive increases in tree density. The picture to the left is one of my favorite places, the Sierra San Pedro de Martir in northern Baja, Mexico. It's a forest that occurs in the upper Baja Mexico Peninsula, the peninsular mountain range that actually abridges both San Diego, San Bernardino, and goes into Baja. You can go there today. You fly to San Diego, get your passport, drive 6 hours. You go there today. These are Jeffrey pine, white fir. This place has never been harvested, and fire suppression didn't begin until 1970. So when you go down there today, I've been working here for close to 20 years. You find densities here in the Martir today that are darn close to what we saw in 1911 in the Sierra Nevada. They're a little different, and we could talk about that. But the Sierra San Pedro Martir is a contemporary site you can see today, and you have these really open forest, large trees. This actually is what we had in the Stanislaus in an area that we worked at. So what's it look like? Next thing I wanted to just mention is a rim fire. The rim fire, now I think it's the 4th largest fire in California history after the Thomas Fire got into the stats recently, unfortunately. So the rim fire is a large fire that occurs in the Sierra Nevada. Little map shows us down here. Here's the Sierra Nevada, the rim fire. So it's also, turns out, it's right on top of our 1911 survey, just by chance. Over here to the right, again, is Yellowstone National Park, Hetchetchee Reservoir, Lake Eleanor. Off to the left in the green is the Stanislaus National Forest again. Well, it turned out the rim fire burned right on top of our site of data. And one day I was out with the students. So we were measuring areas that we found the section corners, and we were trying to remeasure the sites that had been originally surveyed in 1911. So you can see maybe the date up here, July 2013. Well, the rim fire was September 2013. So we had a crew in here going to the site and trying to take measurements on tree diameters, densities, and things of that nature. And then, lo and behold, they got a call one day in the radio and said, you guys need to get out because we got a fire down the canyon. We're not sure exactly where it's coming, but you're maybe at risk. So everybody got out. Everybody was fine. That was good. But then take a look at this picture. I came back the same day. Here we got a big old sugar pine log on the ground. And take a look then at the next picture after the rim fire. So that's 25 September 2013. And the entire rim fire doesn't look like this. In fact, there's a lot of the rim fire that's restorative, where we don't have big patches of mortality like this that actually cause what I would call ecological concern. Because the trees that are in this picture, none of them have closed cones or serotinous cones. There's a whole set of trees and pines that actually, when they're mature, the cone stays closed. When it heats up, the cone is then opened, seed is released, forest is regenerated. Every one of the species we see in this picture, ponderosa pine, white fir, incense cedar, when the cone is mature, it opens. Seed is actually then released, dispersed by small mammals, forest can grow. But when you have a fire like this that actually kills trees over maybe 1,000 acres, 500 acres, you basically exterminate the seed source of the trees. The seeds don't have an ability to live because they don't have protection from the cone in those other instances. These are the reasons why we are concerned about large-scale mortality patches in the Sierra Nevada, because functionally the seed source of the trees have been removed. The next picture I'll show you was about 18 months ago. I took it out for time. What I would show you there then essentially is we have shrubs growing. The shrub seed bank is in the soil. The shrub seeds can stay viable in the soil for something like 50 to 100 years. So you take the overstory off the forest, and the shrubs then can actually regenerate, grow, and we see a nice native shrub field coming up. And shrubs are great too. Shrubs are part of ecosystems. They're important wildlife habitat. They're all sorts of things. But the challenge is big patches of shrubs growing where forests once were. The carbon stocks of those systems are so much lower in the shrub versus the forest. Sequestration goals for things like AB 32, we need forests to do that. So there's a lot of reasons why having large patches of shrubs really don't probably meet the goals of a lot of ideas in California. Okay. What about another idea? So here, we're back to Yosemite again. Now we're going to a little different place. We're going to a place called the Illilouette Creek Basin. Illilouette Creek Basin is this little area to the bottom that actually is delineated. This is an area of about 45,000 acres, 40,000 acres. The thing about this area that's been interesting is they allowed lightning fire to start burning here pretty much unabated about 1972. Remember, we talked about the NPS policy change that actually happened in '68 that allowed lightning fire to then come into the system again. Don't exclude it. So these are a couple pictures from the Illilouette Creek. We've been working there for about 18 years now. The next picture is essentially the colors depict different fire perimeters over 40 years. So this is a depiction of many lightning fires. Every one of these is lightning, burning in the Illilouette Creek Basin. Some places have burned 5 times, some places 1, sometimes 0. A lot of places 2 and 3. So they just had this reoccurring fire burning in the Illilouette Creek, and that then enabling kind of forest dynamics. Some ways it's like a time machine. Man, do I wish I had a time machine. You know, could you imagine if we could stand right here, hit a button, go back to 1600, and stand in the Sierra, stand somewhere else, and just get a sense of what's going on, the native peoples, ecosystems. And I don't want to say that's our desired condition. I know climate change is real. It's changing everything. Temperatures are up. We know that the season of fire is actually increased. So the historical idea is not really, I think, the desired condition. But I think it informs us. It just allows us to understand what it once was. That it helps us then to make decisions to the present and to the future, I think, better. So I think some folks put historical conditions, you know, just thinking that climate change has changed so much that it's not useful. I just don't agree at all. I think that you can still use historical data to help us understand the future. Okay, so that's Illilouette Creek Basin with many fires from lightning to the National Park Service's credit. Here's a fire from helicopter. One of my friends took this picture. So this is the 2001 Hoover Fire. It actually burned under drought conditions and pretty good wind. This is Mount Star King. Right over here, maybe about 8 miles, is Half Dome. So it's actually just pretty close to Half Dome in terms of its location. And you can see a bunch of smoke going up. And, you know, no doubt smoke management is a big concern. Okay? Public health, all sorts of reasons. But if Yosemite National Park can burn areas almost every 5 to 10 years right next to the valley, where probably 3.5 million visitors come every year, and they're able to do that with a smoke management plan and actually trying to basically achieve goals simultaneously, it just tells me there's opportunities for more fire to be in our ecosystems. If Yosemite can do it with all those tourists in the valley, and once in a while they smoke them out. I was down there 2 years ago. I got totally smoked out. I couldn't even see the other side of the crazy valley because they were allowing lightning fires to burn in parts of the park. I give them credit for that. There's no doubt they're taking heat for it because, you know, I planned this trip from Japan. I've come here. I can't even see Half Dome. So, you know, but overall, you know, what about the ecosystem character? Here's a picture of an interesting place where we've had forest, lodgepole pine and fir, converted to a meadow. And from me walking around on this site for a number of years, I realized that there were some places where forest was really changing and going to something very different. We started to do some work on this. In 1970, there was essentially a photograph taken of the entire park. We then did an analysis of it. The green is essentially forest cover. So you can see 1970, the last fire in this site was 1874. About 100 years of fire suppression until 1970 when this photograph happened. Then we did an analysis of it. Over here in 2012, this is what the Illilouette looks like almost today with the different covers depicting different vegetation. So we see sparse grassland, shrubs. So what we see is the wet meadows increased by 200% from the fire regime being brought back. The dry meadows up 200%, shrublands up around 30%, but forest covers down by 22%. So we're seeing more heterogeneity, more dispersed vegetation. We're not seeing that really that huge monolith of forest canopy. And we were interested about water. So I've got some colleagues from Berkeley working on this with me, Sally Thompson and others. And Illilouette Creek is down here. If you look at the water leaving Illilouette Creek since 1974, when fire regime was actually reestablished, it's either stable or slightly increased per unit water input. The areas that are in purple, none of these areas have any real fire, a little bit there, but most of them are areas that have had very little fire in the same period. Every one of those had significant decrease in water output since 1974, every one of them. So I think in some ways there's more research needs to be done on this, but it looks like the fire management that's happening in the basins also moderating water even in a changing climate. That's pretty big. Roger Bales does a lot of work on this from UC Merced, really probably one of the experts on it. But when I see this actually having a water co-benefit, it gets my attention because of just how important water is in this state. The other thing it did too is Gabrielle did an analysis of mortality from the drought and bark beetles in here. It turned out to be less than 1/5 outside. I think it was actually less than maybe about 5%. So the reduction in tree density that occurred, probably more recharge to groundwater and other aspects, enabled the trees that live there to actually persist through the drought and bark beetles versus what happened outside. So the management response, fuel treatments are really possible. The idea of maybe increasing scale with managed lightning fire. How are we doing in terms of managed fire? I want to make sure I have plenty of questions coming up. This is Malcolm North's research. Here, essentially, what he tried to do is, there's all the different fire forest types in the Sierra Nevada in the different colors. And if you look at pre-1800, this is the amount of area he thinks used to burn in the Sierra Nevada Forest Service lands before suppression, about 500,000 acres on an average year. Over here to the left is basically what we're doing today. What we're doing today is on the order of maybe 40,000, 50,000 acres a year. If you continue this effort forward for the next 40 years, essentially what you see is this amount of area of the Sierra Nevada will never receive a treatment. Almost 3 million acres. I call that a freight train. Here we got climate change right down the pike. We've got increased ignitions from both people and lightning. And we have a forest ecosystem that has no capacity to deal with stress. So when I look at this, this is my panic button, or let's get going. Because I worry of having this much forest area, all the carbon, wildlife benefits, all that stuff, and then you're going to keep it in that condition, and this is the effort we're doing. That's why we got to do better. Let's talk about some policy revisions for a moment. This came out of a paper I wrote 2016 with Eric Biber and a couple other colleagues. In the paper we think that current resource-specific policies are so specific and focused that in some ways I think we're missing that we have endangered landscapes, mostly forests in this state. So this idea that we're focusing so much on some resource-specific ideas, we may be missing the big picture. We argue in the paper that forest restoration should therefore be at least equal to other policy priorities such as endangered species, clean air, and clean water. We got some good laws in this country, the Clean Air Act, the Clean Water Act, Endangered Species Act, all signed by Richard Nixon. They're pivotal. They created so much good stuff. Wildlife habitat, clean air, water. But today, I'm afraid, my view is, and maybe you'll disagree, I think they're silos. I think people are focusing on those things too much, and they become then like the essence versus the forest ecosystem. If those systems are not evolving with climate and fire, I don't know how you get these other co-benefits. That's my view. And I think forest restoration, therefore, needs to stand as a standalone objective. I would actually argue that we might need federal legislation that actually would put it on par with endangered species, clean air, clean water. Right now, we don't have it. So it's almost like, well, of course we want that, but in some ways it's hard to do in the current policy environment. Ensure fire suppression funding does not actually impede fire prevention. This is something Congress has been debating for at least the last 4 to 5 years. They get close to passing that. The idea of trying to get FEMA to cover some of those costs versus the Forest Service and Interior always falls apart because someone wants to add something else in at the last minute, it seems. I'm all for this to try to get more funding for restoration, but by the way, if you got funding, you better get some work done. Engage in collaborative planning to basically ensure fire-wise communities, wild and urban interface, trying to do better in terms of where we build communities. And maybe the idea of cost-sharing fire suppression with those communities. That's another controversial thing, the idea that maybe not the Forest Service or the federal or the FEMA are always going to be the ones that are going to pay for suppression, sometimes post hoc, but maybe you're going to have a cost-sharing up front that allows local communities, counties, and the state to actually provide services and not being reimbursed by FEMA. That's expensive. But it might enable better planning in the urban wildland interface. And then increase education and outreach to enhance fire prevention to assist with current problems. We have some ideas of what to do. Better ways to build communities, better ways maybe to enhance restoration, better ways to think about climate change and fire. Putting some folks in communities that can facilitate those discussions, city councils, board of supervisors, county planning, NGOs. I think that's a really good, interesting idea. Just have the ability to have communication to the people in the state at the county level. There are things we could do better. It's not going to solve the problem, but it could reduce losses and probably enhance things like forest restoration, resilience, and other aspects. Increase public-private collaborations. The private side of this is important, and so is the public. More training, building skills for prescribed fire. You know, we don't do a lot of prescribed burning right now. That just means we haven't got a lot of history of it. If we think about Florida and some other places where they've had a great history of it, they've been doing it for decades. Florida burned 1.2 million acres prescribed fire in 2017. We did something on the order of 40,000 acres. It tells us we have to train ourselves to think about how we're going to do that and achieve it for longer purposes, and that's just going to take time. I think half a generation. If we want to do that in earnest, it's going to take time. To get people trained, the ability to make mistakes and not have their jobs gone. There's no doubt there'll be mistakes when you do something like that. All fire on land is risky. You're trying to reduce risk, but I think it's another piece. And the idea of maybe wood processing facilities, be it from biomass, maybe engineered wood products, some ability to use biomass. That's another part of this. You know, we have biomass that somehow needs to be used that can almost help with carbon sequestration. And as climate increases and changes, I think it does try to help us to quickly facilitate some ability to get resilience and adaptation. Here's the last slide. So fire forest adapted to low to moderate severity have changed. I'll be honest with you, there'll be some people in the room that would disagree with me. I know them well. Maybe some of you know them. They would say that, no, Scott, we haven't seen that kind of change. And by the way, the rim fire was 100% restorative. I've heard them say that in public settings. I disagree flatly. I think the science is clear on this too. The science says that no, the rim fire is not restorative, and no, we don't have conditions today that are somewhat similar to what they were pre-1800. That's another conversation. But climate change makes this worse, but it's not the biggest factor, in my view. The biggest factor is forest conditions. If you go down to the Sierra San Pedro Martir, they had a severe drought, 99 to 2002, very severe. And then an area burned down there that we worked on. After 4 years of drought and a wildfire, 20% of the trees died. 80% lived. That's a victory. So it shows us that there really has some capacity for these forests to work. Increased fuel reduction, back of the envelope calculation, 10 times what we're doing today. I tell people that sometimes, they say, you're nuts. What about 5 times, 3 times? I just think we make a plan to try to show that we can achieve a larger, more restorative outcome, prescribed burning, managed wildfire, mechanical treatments. What we're doing right now, it's not working, period. That's my view. It's not working. I worry the next 1 to 3 decades is critical. I taught my first class at Berkeley, a class I just, fire ecology. I said, class, you are going to be the generation that's going to make the difference. Because you are going to be the next 10 to 30 years, your careers are going to span this period. And I think, and I'm optimistic, that you're going to make a difference and actually help us solve this problem. I'm an optimist. I really am. I really think we have the capacity. There are challenges, there are uncertainty, but I'm an optimist. The forests and the ecosystems of this state are too bloody important. With that, I'll just end and acknowledge some, wrong way, acknowledge some friends and some colleagues. Thank you.